Okay, recording has started. So let me first introduce myself and then we will start the session. I am Karan Kumar, PMRF student at IIT Guwahati, and I am the course TA, one of the course TA for this biochemistry, which is on NPTEL. So you might be aware about that these weekly sessions are conducted every Friday. Uh, and then in this session, what I will talk about, I will talk about how to solve the assignment problems which is for the current module, protein structure. Okay, and then these sessions, in this session I will also discuss what kind of problems you can see in the competitive examination from this topic and how to approach those problems. Apart from the assignment problem, I will also share some different problems which might be useful for you. If you solve it, it can help you in your competitive exam, it can help you in your semester exam, and also in this course exam. So uh, let me go through the interaction session. So the content of this live interaction will be, first I will introduce myself. If you have joined the previous session in week like on 3rd February when these sessions started, so there also I introduced, but because these sessions will be recorded and uploaded on the YouTube channel, so I am introducing myself. Then about the course introduction, a brief introduction, and about the live sessions. Then we will revise the week 2 topic in very short span, not complete, because I hope that you have gone through the lectures that are already there in the NPTEL portal. And then few topics I will take up. If you are stuck in some concepts, then I will clear those doubts. And then we will go to talk about the scope of this topic with research perspective. Then important topics of chemistry and biochemistry in GATE exam. So these are the live session contents. So who I am? I am senior research fellow at IIT Guwahati. This is my email ID. You can email me on this email ID anytime if you have any doubt related to this course content or this live session. You can also post your question in the group discussion forum of this course. I have done my BTech from NIT Calicut. I graduated in 2018 in the Department of Biotechnology. These are my different professional handles that you can also explore to know more about me. You can also check my website, which is www.itg.ac.in/stud/karan18 to know about to know more about me and my research topic and PhD topic. Other NPTEL TA who will be taking are Shiva and Mohan. They will be taking on Tuesday and Sunday from 7 to 9 p.m. And this is the NPTEL course information. You can find the course registration link. When I will share this PPT also with you so that all the contents will be accessible to you. And these sessions are for we conduct this session for regular draft clearing session. Then these are the part of annual PMRF deliverable. Then recording session will be uploaded on the YouTube channel. Do follow the YouTube channel, which is www.youtube.com @YouTube @WinBioCV 2022. Okay. If you click on this hyperlinked channel, you will find the URL of this YouTube channel. You can follow it, and the PPT and resource material will be shared through the email in the course forum. Now the concepts that were covered in week 2. This is week 2. Okay. In week 2, you must have gone through the peptides, polypeptide, and proteins. Then hydropathy index and interaction with water. Orientation of amino acids residue in solvent. Torsional angle, which are also known as dihedral angles of CN bonds and CC bonds, and Ramachandran plot. The primary structure was discussed, secondary structure, tertiary structure, quaternary structure, then rotation around the bond in polypeptide chain, that was also discussed. Then feature of beta sheets and alpha helix, how many hydrogen bonds is formed, and what is the fate of what will be the direction of the helix, what will be the direction of the beta sheet, acid, and based on that which name it will have. So that all things were discussed in the previous session, like in the weeks module lecture. And then ma'am also talked about helical wheel. So I hope these concepts are clear to you. If those are not clear and you still have some doubts, you can ask me during this during this session, and also you can post in the Google forum of this course. So few general questions that I want from you, like I what do you understand from the protein architecture and protein structure? You have gone through the week 2 lecture, so can somebody brief me what is protein architecture and what is or protein structure in a very brief kind of frame? Can you define it? What do you understand by this term? Anyone? See, this is an interaction session, so I hope you participate in it. Otherwise, it will be kind of a recorded lecture only. So you and there is nothing wrong or right answer. You can ask or you can ask or suggest anything that you want. So try to interact. So what is protein architecture? Yes. Please unmute. Okay, who all have joined? Okay, can somebody answer this question? Okay, then no problem. The another question is, what do you understand by protein architecture and why is it so much important in biochemistry?
Protein architecture tells about the properties.
Yes.
Its
What
properties
kind of
define
properties?
the physical properties and the chemical, biochemical properties, the bondings, clash bondings, and hydrophobic. The hydrophobic bondings are in, in the non-polar bondings and the polar bondings. They
Yes,
are
very
important.
nice. Yes, yes, yes. Go ahead.
And there are van der Waals forces in that quaternary structure.
Yes.
That also defines it, differentiates proteins.
Very nice. Very good. See, the language is also not a problem. If somebody is not comfortable in English, they can also talk in Hindi. So yes, if somebody wants to talk, they can unmute themselves. Yeah. Who was talking? Yes, as Vinay answered, and he tried very accurately, he defined. So, what I want to add, the answer to the first question is, what do you understand by protein architecture? Protein architecture means in a protein, like if you are studying a protein, why you want to understand a protein or why you want to understand a biomolecule, which is either micromolecules or macromolecules, because they participate in in all systems, all biological systems, whether be it the very simplest one, which is virus, from virus to human body, which is very complex organism. So like mammals and other humans. So there the in human body there are many cells and millions of proteins in the human body. So how how does all different proteins have the different behavior in the environment that they are in and where they are functioning? So this all thing depend on their architecture, how they are which amino acid composition they have, in which environment they are present, what the individual amino acids character, whether it is physical character or their chemical character. Because in the last class, like in last week, you studied about the amino acids. So individual part of amino acids. So the different properties of amino acid, physicochemical properties, biological properties, then their like hydrophobicity, hydrophobic nature, and these all things. So to go more deeper, to understand a behavior of protein, we need to understand its architecture. Okay, protein is nothing but it is a polypeptide chain, right? In its primary form. So how the different amino acids will come and be forming a bonds, non-bond like non-covalent bonds, which holds the protein arc, which is the backbone of a protein. So how these bonds are forming, this also depends on the which kind of protein, which kind of amino acids it has, which so these all things are very much important. And why understanding the protein architecture is important in biochemistry? Because whatever happens in our body, all chemical reactions, all are because in all of them you will see the protein as a main character, which will be playing a role, a very crucial role. Okay, so understanding the behavior of that protein, understanding its architecture is very much important in understanding the biochemistry of human body, biochemistry of any chemical reaction, or biochemistry of any organism that exists in nature. Okay, so scope of this topic with research perspective that we will talk about in the like last last when we will be winding up this session, and then what type of gate questions are asked from this topic, that also we will discuss throughout the lecture. So the first question that I want to ask is you need to identify which statement is or are correct about the protein in non-aqueous solvent. Okay. The important thing whenever you are answering a question or you are attempting a question, the first thing that appears, the how you will like attempt this question, that depends on understanding a question itself. First try to understand which all informations are given in question itself, and then try to explore about those topics, and then try to understand what could be the correct answer. So here your question itself has given that your protein is in non-aqueous solvent. Non-aqueous means not water, right? So now you try to explore each and every option and then try to understand which option is correct. So your options are placement of hydrophobic amino acid residue within the interior of protein. Option B, placement of polar amino acid residue around the exterior of protein. Option C, placement of hydrophobic amino acid residue around the exterior of protein. And option D, minimization of entropy by the formation of water solvent cell around the protein. So can somebody attempt? What will be the fate of protein in non-aqueous solvent? Anyone? Okay, if you are not able to answer, then I will discuss this question, but try to give any answer. Yeah. Somebody was talking. Yes. Any guess? Okay.
C.
C, option C. Very good. Placement of hydrophobic amino acid residue around the exterior of protein. So can you elaborate more about this answer? Like, why do you think that hydrophobic amino acid residue will be in exterior?
Mostly they hide the hydrophilic.
Yeah,
Hydro,
in non-aqueous, yes. In
hyd-
non-aqueous environment, yes, yes.
it hides hydrophilic. Hydrophilic so
Ah,
hides the hydro.
yes, yes, yes. And why does that happen? Because, like, see, think, uh, if uh, if surround the protein, if aqueous environment is there, then what aqueous environment will provide that the aqueous environment contains water molecule, so they will form the hydrogen bonding. They will try to form the hydrogen bonding with the protein residue which are on the surface. So let us say when water is there, then on the surface hydrophilic amino acid residue will be playing an important role of stabilization of the protein. Why? Because they can form the hydrogen bonding. So when the solvent is non-aqueous, then in that case, if hydrophilic amino acid residues are on the surface, they will be then the protein will not be stable. Why? Because it will hide, like the protein will try to hide those hydrophilic amino acid residue in the core. On the surface, there will be hydrophobic interaction. So because of that, hydrophobic amino acid residue will be present at the exterior of protein. So option C is correct here. Very good. So second question is, the quaternary structure is possible for a protein only when option A, the amino acid cysteine is present. Option B, all amino acids have non-polar R group. Option C, two or more polypeptide chain are present. Option D, a protein chain bends back on itself. So what is your take on this question? Anyone? Anyone can answer. Yes, Manisha? Okay. See, why quaternary structures are there? Because when in a functional protein, when only one monomeric chain is not interacting, like it's not participating in the chemical reaction, or in the for being a functional protein, two or more subunits are required to form the quaternary structure, and that is not true for all proteins, because some protein may act in monomeric form, they can act as a functional protein, but when there is a quaternary structure, then you will see that two or more subunits are interacting. Subunits are nothing but the monomeric form, which is the polypeptide chain, right? So when there are two or more polypeptide chains are present, then it is the possibility that the protein can form quaternary structure. So the option C is correct here, right? Quaternary structure has nothing to do with the type of amino acid. It has nothing to do with the nature of amino acid, whether it's polar, non-polar, or it has nothing to do with which kind of turn or something it is forming. Quaternary structure means there are two or more polypeptide chain which may possibly interact in the hydrophobic fashion or non-covalent fashion, so that it can interact and form a quaternary structure. Okay. Of question number 3. Is it clear to everyone? Whatever I'm talking about?
Yes, sir.
Yeah, thank you. So your question number 3 is, which of the following does not affect the stability of alpha helix? Stability of alpha helix, right? So before attempting this question, can you tell me in alpha helix which kind of bonds are prevalent, so that the stability depends on which kind of like uh, answering this question is the similar to like avoiding all the different options. So can you tell me the what kind of bonds are responsible for stability of alpha helix? Anyone?
NH,
Yes.
CONH,
CONH, that is the peptide bond. CO and C double bond O NH is the peptide bond that occurs in all kind of secondary structure, and it is essential to bond. The peptide bond is essential for forming that, for joining two amino acid, but that does not mean it is exclusively present in alpha helix. So if alpha helix is there, or beta sheet, or any kind of structure, the peptide bond will be there. So what is the stable? Which bond determines the stability of an alpha helix? See, The stability of alpha helix is determined by the hydrogen bonding, right? Because in secondary structure, mostly the hydrogen bonding is the prevalent, be it random coil, be it alpha helix, be it beta sheet or beta strands. Beta strands is nothing but there are more than one beta sheets are there in one cluster, and then they form a beta strand. Yeah. So in both of the form, like whether it is alpha helix or beta sheet, hydrogen bonds are very much important, right? So the question was, which which of the following does not affect the stability of alpha helix? See, if hydrogen bonding is there, it will affect the if there is change in hydrogen bonding, it will affect the alpha helix. So obviously, hydrogen bonding is not the correct answer here. Now, the bulkiness also affects, right, the interaction between the R group, because alpha helix, when there are two R groups present on the same side, okay, so there will be a steric hindrance. So the interaction of two R group also determine whether the alpha helix will be stable or not. Right. So that is why option C also talks about the stability of alpha helix. But what does not determine the stability, what does not affect the stability of alpha helix is option D, because occurrence of alanine or serine residue that may be present in the alpha helix, but it does not affect the stability of alpha helix. So the correct answer here is option D. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yeah. So now coming to the next, like this concept based on these three questions, they were related to the what kind of amino acids will be present. Then to answer the second question, you should know that like what kind of structures occurs in protein folding, right? What are the different type of forms a protein can take. And the third question was mostly related to the which kind of form alpha helix, which kind of like secondary structure geometry exists, and how this stability occurs. But before that, what is the important thing is to understand the peptide geometry, right? Because till now in the week one you studied about the individual protein, individual amino acid, but in week two you are studying the protein architecture. To understand the protein architecture, you must know how peptide bonds are being formed. I also talked this in the like last part of my last live interaction, but now I will again take up so that it flow through. It's continuously flow. It is a kind of continuous. So to form a protein, like to join two individual amino acid, you must remember the protein sequence, protein chain flows through N terminal to C terminal. Okay, N terminal to C terminal. What do you mean by N terminal and C terminal? N terminals are nothing but where the amino group will be present on the left side, and in when the peptide chain is ending, then you will find at the end you will find the C terminal. Right. So the direction of any polypeptide chain should be from N terminal to C terminal. On the left side, you should have amino group. On the right side, you should have carboxylic group of another amino acid. There are two amino acids here, first amino acid and second amino acid. And the bonding occurs between the carboxylic end of the first amino acid and amino terminal of the second amino acid. Okay, and due to the condensation reaction, water releases and this forms a peptide bond. This forms a peptide bond, and now this is called the peptide backbone. This is peptide bond that occurs in all kind of protein. This is the backbone of a protein, right? Now see, if both of the side chain are present on the same side, that conformation you will tell as a cis conformation, right? That is what you have studied in stereochemistry in your chemistry notebooks in your 12th, right? So but when the two side chain are on the same side, it is called cis conformation. When it is on the opposite side, it is called the trans conformation. But let us assume that there is a bulky group both side chain will be bulkier in nature. Means can somebody name any bulky side chain? Amino acid having the bulky side chain? Which amino acid has the highest molecular weight? Can someone recall?
Tryptophan.
Tryptophan, very good. Tryptophan, phenylalanine, these are the bulkier side chain, right? So let us say if both the R group are tryptophan side chain, both amino, that means both amino acids are the tryptophan. So in that case, if the both side chain will be on the same group, same in the same side, what it will create a steric hindrance while it is folding, right? So that is why the cis conformation of peptide chain is not much you do not see much cis conformation. Always you will see peptide bond exist in the trans conformation, right? So here, what is the another thing you need to understand? You need to understand the property of peptide bond. So what are the what is the important thing that you need to remember about the peptide bond while you are studying the angles? So see the peptide chain, normally you see it you see a kind of rotation around the single bond, right? Let us imagine you are holding hands, okay, and if you are only holding one oh, let us say it is one mass is there and it is bound by, like there are two protruding kind of metals, okay. So and you want to rotate this object using your hand. So if there are two bonds, like two rods, it will be difficult to rotate. And if there is only one rod, you will be able to easily rotate this rod, right? In its like this fashion. Tell me which one will be easy to rotate? One or two?
One.
So one.
Yes, one. So that is why rotation around the single bond is very easy, right? And normally the double bond or pi bonds are not able to rotate, like you, there is a very less chance of rotating the double bond. So that is why double bond does not form the rotational angle, right? And let us say, so if you are studying a rotational angles and all, why you are studying a rotational angle? Because only one you will not be seeing only one kind of form of a particular amino acid, because there exists a single bond character and there can be possible rotation around those angles, around those single bond. So that is why in peptide also you can see these kind of rotations. Based on the rotation, there are different angle that exist in peptide bond. Okay, so not only peptide bond, I am talking about the backbone, right? In peptide bond, which is CONH bond, normally this does not exist only in single bond form, because the lone pair on nitrogen can participate in resonance and it forms a double bond on this CN bond, right? It has a partial double bond character, and in that state, this CO will exist as a CO minus, right? And there will be a partial double bond character, because of which there is a limitation of rotation around the peptide bond. Okay, you do not see the rotation around this bond, and the character as a rigid structure and planar structure, because you must have studied that when you find the pi bond in a ring. See, I hope you all are aware of the hybridization that exists in the bonds. So normally single bonds are sp3 hybridized, right? These are the sp3 hybridized, means it has the involvement of all like 3 p orbitals and 1 s orbital. But when there exists a double bond between the two atoms, in that state, this particular atom will exist in sp2 state. Okay, so this is sp2 hybridized carbon. This one is the sp3 hybridized, and this one is the sp2 hybridized. Right. So there the possibility is that this bond may rotate due to the rotational forming, but this bond does not rotate. Okay, so similar thing can happen here also. The rotation is not possible around this particular CN bond. In peptide bond, in this CN bond, the rotation is not possible because of the partial double bond connector, but it also exists because it is not fully double bond character. So also there is a rotation, but that rotation is very minimal. Okay, and that rotation, that rotation is called as, that angle is called as omega angle. Okay, there exist two other angles also, which are known as the dihedral angle or torsional angles, and those are psi and phi. So where do you find psi and phi angles? Psi and phi angles exist. So before going that, let me first tell me what are the torsional angles and why you need to study the dihedral angles. Can somebody tell me why it is important to study the torsional angle or dihedral angle? Anyone? Anyone want to answer? Okay, no problem. So why ma'am has cleared this thing in very very good way, where she shared about the different presence of different number of atoms. Let us say when you have only diatomic molecule, which is hydrogen H2. Okay, in that case, to define its geometry, where it is present or not, you only need the distance between these two atoms. That if you know the atom position of one atom and you know the distance, then you will have the information where the second atom might be present. Right. So to define diatomic molecule, you only need distance. But when you have more than two atoms involved in a molecule, let us say you have like water. Water has three atoms, one hydrogen, then oxygen, then hydrogen. Right. So to define this particular molecule, if you tell only the distance between one hydrogen to another oxygen, then another oxygen to another hydrogen, then that can tell you only the where it is present, but you will not be having the correct structure of hydrogen water molecule, because you don't know the angle between these two bonds. Once you know this angle between these two bonds, then you will be able to correctly define how this water exists in geometry in 3 dimension, where its coordinate will available and what are the angles between the two bonds. Then you will be able to specify the geometry of that particular water molecule. That is true in all molecules which have three atoms. Okay, so for three atomic system, you need distance as well as bond angle. Right? Okay. Let me check whether ma'am has joined the session, because
yes, Karan, I have joined.
Okay. Thank you so much, ma'am. Yeah, ma'am, do you want to interact with students?
Yeah, sure,
Yeah,
absolutely.
So thank you so much, ma'am. Thank you.
Okay, so a very warm welcome to this course. I know I'm a bit late. I was out of station last week. I was in Delhi for another meeting, so I couldn't get to you. And Karan, I know, is doing a wonderful job. I joined a while ago when I was listening to the way he has been the PMRF-TA for a previous course of mine. So I know how he conducts his sessions and what a thorough job he does of it. So I know the course that you are doing in biochemistry has been recorded many years ago. I think 2005 or something. So some of the terminology of biochemistry does not change, but obviously the way of teaching and the methodologies and the let's say the internet facilities or the books available to you have definitely changed over the years. So I know, as Karan was saying, your dihedral angles are not going to change for the protein, but the way it is interpreted and the way protein structure has evolved over the past 20 years is going to be a bit different, though this is the basics of biochemistry. So there are 2 points here. One is this PMRF sessions that you have, the live sessions, which are being conducted in this way because actually the instructors of the course do not have been asked in the past to do this, but we have not had time. So it is worked out in such a way that this PMRF-TAs take care of this whole situation. And in addition, you have a discussion forum, which is taken care of by another set of TAs. So you are welcome to ask questions in the discussion forum, and more so with Karan and the other TAs where you have this live session. So you have definite interaction with the teacher or with the instructor. So is there anything anybody would like to say about the course or anything you would, it's not that we can add anything here, but we can obviously, since we know your emails or we know how to put up something in the Teams, we can add some additional material there. So does anybody have anything to say? Very shy set of students you have, Karan.
Only few usually interact during the session, but most
That's
of them.
always the case with classes also.
Yeah.
And
Yes,
with
ma'am.
online, you cannot see anybody. So you don't know whether some in our
Yes, ma'am.
online classes, we have had the experience where students are there, but they're not there. So, but I guess
Yes,
those
ma'am.
who come here would definitely be interested
Definitely be
in
interested.
learning
Yes.
biochemistry. Yes, I
Yes, ma'am.
believe
Yes,
that. I
ma'am.
believe so. So does anybody have anything to say? Anything related to the course or otherwise, or anything you would like to see that come up so we can put a request to NPTEL to have an arrangement for a different type of course, because all of you may not be related to biochemistry directly. Well, I guess not. Anybody have anything to say?
Yeah.
You can say hello at
Yeah, I
least.
think Rinku has unmuted. Yeah.
Okay,
Rinku,
Rinku,
go
yes,
ahead.
Rinku.
Good evening, ma'am. Thank you so much for your lectures. Just मुझे ये बताना था कि लाइफ साइंसेस के और भी लेक्चर प्रोवाइड कर सको तो, क्योंकि हमें
What
घर पे
kind of
बैठ के अगर IIT टीचर से
So what kind of specific topics would you think are you would require? Any specific topic? Then I can
like
request
biotechnology regarding, yeah,
biotechnology.
I want to learn basics of biotechnology. Yes,
Mm-hmm. Okay. So then I
regarding
will ask
cell
because
cycle.
okay. So then what I will do is I will ask our NPTEL office to because they have a listing for a course offering. So we will then request any biotechnology professor to actually take that up. You want to have a course on the basics of biotechnology. Okay, sure. I'll make a note of that and I'll send it to our associate dean who will take care of this. Okay, we can send it to the Madras. Madras is the
Thank you.
NPTEL coordinator. I'll definitely do that. Okay. Anything else?
Thank you so much.
Okay. Thank you for joining this, and thank you for joining the course also. You're always welcome to ask your questions and interact. And because biochemistry or protein chemistry is something I've been working for the past 30 plus years, probably older than a lot of you. And it has fascinated me and it still fascinates me. I'll be retiring in a few years, but I'm still extremely fascinated by the whole concept of protein chemistry. It's just marvelous the way nature has defined or designed our whole systems and how the processes work and how proteins fold, how they interact, how you have the specific biological functions, all your, I was just telling a thermodynamics class, a biological thermodynamics class the other day, of how talking about glucose breakdown. Glucose breakdown has a positive free energy change, indicating that it is a non-spontaneous reaction, and nature would want it to be non-spontaneous because you do not want your glucose to be constantly breaking down. So you would have to couple it up with ATP, which has a negative delta G, and then together they would have a negative delta G, giving a spontaneous reaction when it is coupled with the ATP hydrolysis. So if you just think of these little things that nature has actually defined or designed, it's just amazing, just amazing. And I'm glad, or I'm happy that you are also fascinated with biochemistry. It takes you a long way. And when you understand these small details of how nature has defined or designed these, it's just wonderful. Okay, so keep being curious. And I always tell my students, continuously ask questions. Whatever you do, whatever you study, always ask the question why. Why am I studying this? Why am I doing this? Why am I learning this? Why are we doing this? What information are you going to get from this? Okay, so Karan, anything else?
Thank you, ma'am.
Yeah. Anyone want to talk? Yeah.
Thank you, ma'am.
You're most
Good evening,
welcome.
ma'am.
Good evening.
When the biochemistry courses exam will start on?
I think it's sometime in April. But every week you have assignments, right? Every week you have assignments, and those are given by the other TAs of the course, but they're pretty much what you are doing in class. So I think you already have, how many weeks of the course? This is the second week, right?
This is second. Yes, ma'am. This is second week.
So every week there is one assignment. Okay, but the exam course is in April. The exam for the course.
Thank you.
Okay. And if necessary, I know Karan is doing, but then at the end I'll join again once at the end of the course, or anytime you want me to just come. But I know Karan, I have known Karan for a long time now because he took care, as I mentioned, of my previous course. So even being he's in his final years of his PhD, so even though he has a lot of work to do, and he has also opted for helping you with the GATE exam for which is going on right now. I guess this week and last week and the coming week you have the GATE exam. So that Excel is, I don't know if it's still called Excel, GATE Excel paper for biochemistry, where you have an option of biochemistry. So those things will be very helpful to you, I hope. Okay. Okay, then I'll take leave now.
Yeah. Thank you so much, ma'am, for joining and interacting with the students.
Sure, always.
And
always.
it is always listening to. Yeah. Just Gayatri.
Ma'am, which book should we prefer for detailed study?
Books, see, the books that when I did the course, or when we had Leninger and Stryer, but now Voigt and Voigt is used a lot. Voigt and Pratt, that is one book that has come up over the years. But the time the course was done, we used Leninger and Stryer. But as I said, the biochemistry content has not changed much, just the approach or the way it has been, or the way it is written. So Voigt and Voigt is a good book. It's a standard biochemistry textbook now.
Okay, ma'am. Thank you.
Okay. Anything else?
And provide previous year question.
Previous year questions. Okay, I'll send them to Karan so that he can discuss with them. Sure, absolutely. I'll do that. Okay, I'll send them to Karan, or I'll send them to the group of PMRF so that they can discuss the questions pertaining to every topic that is being covered. Perfect. I'll do that. Yeah.
Yes.
Okay. Okay, then I'll hand it over to Karan so that he can continue with his discussion. Okay. Yes. Thank you all for being there, and continue to be here and enjoy the course and enjoy the learning. That's more important.
Yes.
Apart from enjoying the course, enjoy the process of learning. There's a lot to learn and a lot to do. Okay, bye. I'll see you then later. Bye.
Thank you so much, ma'am, for joining and interacting with the students.
Okay. Absolutely. Okay, bye.
Bye. So we were discussing about the distance, like the dihedral angles. So these dihedral angles are normally between the two planes. The planes normally being defined by the involvement of three atoms. Let us say for three atomic molecules, only you will need the distance between the two atoms and also the bond angles. But when you are defining more than three atoms, like let us say about hydrogen peroxide, then you not only need the distance bond angles, but you will also need another set of kind of parameter, which is called as a dihedral angle. So what are dihedral angles? Dihedral angles are the these are the angles between the two planes, and normally you know already in geometry, you must have studied that planes are defined by the involvement of three atoms. So let us say if there is a plane here, one plane here involving HOO, then another plane will be this one HOO. So the angle between these two planes, that will be nothing but the dihedral angle. And if you know this dihedral angle, then you will know the correct coordinates of all four atoms. So that is why when the same thing apply to the protein also. So to study a protein or a peptide, you you must know which all the which all the different informations parameters are available, like the when you see a PDB structure file, then in that PDB structure file, what all information you will get, that the position of each and every atoms, then the distance between the correspond adjoint atom, the angle between the two bonds, and the angle between the planes. The plane contains three atoms. So in that scenario, so when in the peptide bond itself, like this backbone C beta, normally when how peptide bond is formed, in peptide bond you will see C alpha and N C alpha C, right? So you will see the geometry as here O, C and H. This 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 makes the peptide, the plane for peptide bond. And other than that, if you go one atom behind and one atom forward, then you will see the two other plane also in this backbone, right? So the angle between these two planes are termed as phi and psi angle. Okay, and phi angle is defined between the plane of this N C alpha. There are two here. Yeah, there are two planes, and in between the phi angle is normally the bond rotation between this N and C alpha, and from C alpha to C beta, you will see the bond rotation, and that bond is known as the psi angle. Okay, so this is how you define the dihedral angle, and dihedral angles are important because to know whether the protein is correctly folded or not. So in that sense, you study the Ramachandran plot that ma'am has discussed in her lecture. So another information you must know about the peptide bonds are the four atoms involvement of O, C and H that lie in a relatively rigid plane because of the pi bond character of C and N, this C and N. And the planarity is due to the delocalization of pi electrons over N, C and O, because here the this the the lone pair electron participate in resonance, and because of that you see this particular pi electron is delocalized over O, oxygen, carbon and this nitrogen. Okay, and this gives the maximum overlap of contributing pi orbital, and you must be aware about the overlap of the electrons over the atoms. These are nothing but the resonance in a pi bond structure, like sp2 hybridized structure. So this is what the different angles that exist in a peptide chain: phi angle, psi angle and omega angle. Omega angle is the rotation around peptide bond. Psi angle is the rotation between the this C alpha and C, and phi angle is rotation between N and C alpha. So based on that, I have designed few questions. So here, an alpha helix is formed by the hydrogen bonding between 6 hydrogen of amine group and the backbone carboxylic group. How many amino acids super upstream of it? Can somebody tell? This is related to the secondary structure geometry of a peptide chain or a protein. Alpha helix, an alpha helix is formed by the hydrogen bonding, right? Between the hydrogen of an amine group and backbone carboxylic group. So how many amino acids super you will find in the upstream of it in one hydrogen bond formation in case of alpha helix? Can somebody recall?
Sir, 4.
Very good. So there are 3 types of helix geometry. One is alpha helix, another is 3-10 helix, and another one is pi helix. Right. In alpha helix, you will see I to I plus 4. In 3-10 helix, you will see I to I plus 3. And pi helix, you will see I to I plus 5. Okay. So normally you will see alpha helix geometry more prevalent in amino, like in peptide chain or in protein. But there also exists pi helix and 3-10 helix, depending on the condition that that particular protein is present. So now the next question is, which of the following best describes the characteristic of a protein motif? Okay, so for that you must know what is the protein motif. The options are a commonly occurring arrangement made up of tertiary structure. Option B, a commonly occurring arrangement made up of multiple secondary structure. Option C, unique arrangement made up of secondary structure found only in single protein. And option D, a unique arrangement made up of tertiary structure only found in a single protein. So what is the possible answer here?
B option, sir.
Option
B.
B for ball, right? B1. Okay. So the answer is a commonly occurring arrangement made up of multiple secondary structure. You are very much accurate. So protein motif is nothing but the the arrangement of multiple secondary structure, and motifs can also be part of a functional group, like functional. So you can see the description here. A protein motif is also known as the super secondary structure, is a defined arrangement of secondary structures within a protein. Okay, it is commonly occurring enough to have an identified structure. An example would be the beta alpha helix, beta alpha beta. Here, beta is also a secondary structure, alpha is also a secondary structure, and beta is also a secondary structure. So here, when 3 secondary structure joints, these are also known as super secondary structure, and it forms a motif. Okay, so while the arrangement is made up of secondary structure, the overall motif itself can be considered as a super secondary structure or possibly even a tertiary. Okay, even though the components of the secondary structure, the motifs do not necessarily have a defined function across the different proteins, but it can participate in the catalysis or binding. Okay, the protein domains, on other hand, defines its functional nature. Okay. Now the next question you have, in the above image, choose the correct option that represents A, B, C structure of a protein respectively. So what does A represents? Can somebody tell what does A represent? What form is it?
A is secondary.
Secondary structure, and more precisely it is
That is alpha helix.
alpha helix. Very good. And option B,
Alpha helix.
alpha helix, and you also find random coils here, right? These are the random coils connecting dots.
Beta sheet.
And here in the C option, like here in C, what do you see? What kind of structure it is?
Quaternary.
Quaternary structure. Why do you think so?
More than one polypeptide chain.
Yeah, more than one polypeptide chain. Yes, this is the tertiary form. This is a secondary form. This is tertiary form. And when two or more tertiary forms comes close to it, and then they form as a functional protein, these are known as the quaternary structure. So the correct option here was option B, right? Secondary structure, tertiary structure, and quaternary structure. Okay. Now coming to the question number 5, glycine and fluorine are the most abundant amino acid in the structure of uh, which option? Your option is hemoglobin, B is collagen, C is myoglobin, and D is insulin. Any guess?
Insulin.
This question was asked in GATE exam, so that is why I have put in here. So glycine and pyrroline are the most abundant in which structure? Any guess?
Hemoglobin, sir.
Hemoglobin.
Sorry.
Okay.
Collagen,
Any
sir.
other
B
option?
option. Sir,
Collagen.
B option, sir.
B option.
Collagen.
Okay.
Collagen.
Any other option? Collagen. More like many of are you in favor of collagen? Okay. The correct answer here is myoglobin. Okay. Collagen also has glycine and chlorine, but correct answer here is myoglobin. Now now let's talk about the different type of state. Like you have studied about it. The single like the chain, the when amino acid is arranged in a beads on a kind of a strand, this is known as the primary structure. Primary structure is nothing but the amino acid chain in bonded through a peptide bond. Okay, when they form alpha helix and beta strands, these are known as secondary structure. When these secondary structure comes together and they form a kind of uh, a three-dimensional geometry, then these are known as tertiary structure. Okay, it might be the functional form of that particular protein, or it might not be the functional form of protein. But when the two or more tertiary structures comes closer, and they form a kind of a globular protein structure when they are interacting with non-covalent bond like hydrophobic interaction or hydrogen bond interaction. So in that case, or you also see like disulfide linkages. In that case, it forms a quaternary structure. So there are total 4 type of structure in which the protein exists: primary structure, secondary structure, tertiary structure, and quaternary structure. Now, how to know the geometry, like how to know in which direction a helix is and how to define a helix? You can this you can fold, like if if your thumb is upside and your finger is curling from like in anti-clockwise direction, then it is a right-handed helix. And if your finger curls around the clockwise direction when your thumb is upside, this is called left-handed alpha helix. The direction will be upside. It will be opposite when your thumb is down. So based on that, how the helix is going up or down, based on that you can find the direction. But how to check whether the protein is going up or down? You need to check because you know that first amino acid in a peptide chain will be having the N terminal, and last amino acid will have C terminal. So what you will check? You will check N C alpha C. C is the this one oxygen bond. So for one amino acid, you will check how this particular is getting progress. So in this case, the lowermost will have N, then C, C alpha, then C. So this is how, if it is moving, then this is called as right-handed alpha helix. And if it is going like this in a clockwise direction, then it is left-handed alpha helix. So similarly, the another important point that you must know about the helices is that what kind of hydrogen bonding characteristic, hydrogen bonding formation characteristic it has. So if a particular amino acid, if a particular the peptide, normally the hydrogen bonding is being formed between the amino acid, like and amino group, like in peptide bond you will see NH right here. So these two, oxygen and nitrogen, both can participate in the formation of hydrogen bonding. So if this is for particular one amino acid, and then let us see one amino acid is here, N terminal here, and C alpha, and C alpha here, right? So in that case, one first amino acid, if first amino acid is making hydrogen bonding with a fifth amino acid, then it is alpha helix. If first amino acid is interacting, it is making the hydrogen bonding with fourth amino acid, then it is 310 helix, because in 310 you will find the hydrogen bond between I and I plus 3. Okay, now let us now these are the thumb rules that one turn will consist of 3.6 amino acid residue in alpha helix. Okay, so in alpha helix 3.6 residue per turn, and the pitch of that helix will be 5.4 angstrom. So based on that you can calculate that 1.5 angstrom rise will be there due to one amino acid residue. How to calculate it? In one turn you will have 360 degree. 360 degree is one full circle, right? As per the geometry. So, and one amino acid take turns of about 100 degree. So in that case, in one full turn, how many amino acid residue you will have? You will have total of 3.6 residues in alpha helix, right? So based on that, you can calculate the pitch will be 5.4 angstrom. Okay, but in case of 310 helix, the pitch will be smaller and there will be more amino acid residue in the, like it, a pitch will be smaller and these will be the tighter one, tighter than the alpha helix. However, in case of pi helix, the pitch will be larger because the amino acid that will be interacting 1 and 7, or not 7, 1 and 6. First amino acid will make the hydrogen bonding with sixth amino acid, and that is how the pi helix is defined, I to I plus 5. Okay, because of that, pi helix will have larger pitch and it will be loosely packed. Okay, so there are two types of strands. One is parallel, another is anti-parallel. So can somebody like recall in parallel what fashion you will see, like how the hydrogen bonding will be there? Which will be tightly packed, anti-parallel or parallel? Based on the lectures that you have referred,
Anti-parallel.
can somebody answer? Anti-parallel will be more tightly packed, right? Because the same set of amino acid will be involved in the making of hydrogen bonds. So when one when one strand is going in this direction and another strand is going in this direction, then you will see that the hydrogen bonding formation occurs in the same set of amino acid. The two hydrogen bond will form in which the end, like this peptide bond NH molecule, this group will form a hydrogen bond with the CO, and the similarly this O can form the hydrogen bond with the NH H of N, right? So Based on that, the anti-parallel strands are more closer to each other and they are tightly packed. The formation of alpha helix only occurs in continuous chain, that you need to remember. Why? Because until unless you don't have the continuation, this hydrogen bond will not be forming, like whether it is I to 3, I plus 3, whether it is I to I plus 4, or it is I to I plus 6. That means the this chains is these chains are continuous. In continuous chain only the hydrogen bonding will occur, and that will form the alpha helix. But that is not true in case of beta strands. One beta strand can have the hydrogen bonding with another beta strands which are much further than the which is first like further than the it's another strand which having the another continuous thing. But the two strands can interact like based on how closer they are, but it does not need to be continuous. Okay, beta strands is nothing but the hydrogen bonding between the two beta seeds, right? Now based on that the questions have been designed. What type of bonds are there in the back, like what type of bonds you considered as a backbone for secondary structure of protein? Understand this terminology very correctly to answer this. Backbone of a secondary structure of protein. Which kind of bonds you will name them? Peptide bond, amino acid bond, hydrogen bonds, van der Waals interaction, or amide bonds?
A
Anyone? Peptide bond.
CONH.
CONH, that is backbone, yes. But see here, the question is about the secondary backbone of secondary structure. So rethink your answer. What do you understand by
Hydrogen.
hydrogen bond? Very good. Because here the backbone does not mean the backbone of a peptide chain or protein. Here the backbone terminology is talking about the support, right? When somebody tells you are my backbone, which means you are supporting that person like in different scenario, in all conditions. So similarly, in that context, when you are talking about the secondary structure, secondary protein structure, so the backbone will be hydrogen bond, because the secondary structures exist because of hydrogen bond, whether it is beta acid or beta strands or it is alpha helix. Hydrogen bond play a crucial role in stabilizing those. So hydrogen bonds are the backbone of secondary structure of protein. Now the next question is, why anti-parallel beta seeds are more stable than the parallel beta seeds? Your options are: hydrogen bond angle is 150°. There are more hydrophobic interaction between the amino acid. Option C, the hydrogen bonding angle is optimized by anti-parallel beta seeds. Option D, the anti-parallel seeds are composed of more stable amino acid. Option E, there are more covalent interaction between its amino acid. Can somebody answer? We have just discussed this regarding the stability of parallel and anti-parallel beta seed. What is the probable answer here?
Maybe C.
Very good. The correct is C. Why? Because in anti-parallel beta seed, the bonding, like the angle, the hydrogen bonding is being formed between the same set of amino acid. Like the two hydrogen bond, one particular amino acid will form. So in that case, both hydrogen bond will be existing in the same set of amino acids, and because of that, it takes 180° bond angle, right? And because of that, the bond angle is optimized in anti-parallel beta acid, and due to which it has the greater stability than the parallel beta sheets. Okay. So in anti-parallel beta sheets, hydrogen bond angle is 180 degree and optimal. This is the most stable angle. In parallel sheets, it is less than 150 degree. Whether the sheet is parallel or anti-parallel does not tell us anything about what kind of amino acid it is composed. So each other answer is incorrect. Right. Now, can you answer this contact map based on the understanding of the angles, based on the formation of hydrogen bond, and based on the continuity and discontinuity of the amino acid in exist in different structure. So can you identify X, Y, and Z in this contact map? What does X represent? What does Y represent? And what does Z represent in this contact map? Contact maps are nothing but yes. C.
C.
X represents helix, Y represents parallel beta sheet, and Z represents anti-parallel beta sheet. Is there any other answer from participant? Here X and Y represents the which amino acid it is. This represents the amino acid number of amino acid number. Like this is 10th amino acid, 20th amino acid, 30th. So the y axis also regarding the same. So contact map mostly maps about the hydrogen bonds. So can somebody give me answer? One answer I have got is C. Another probable answer, if you think about, analyze this graph and then tell me. Any other answer?
I think
Okay,
Y is alpha helix.
Y is alpha helix. Okay, very good. And what about Z and X?
I'm a little bit confused about Z and X, but Y is alpha helix.
So if Y is alpha helix, then you only have A and B, right? Because here Y is parallel beta sheet, Y is parallel beta sheet. So these two answers are incorrect. You have already omitted two answers. Now go about which is correct, which could be the parallel and which could be anti-parallel. And also tell me, why do you think Y is alpha helix?
Z anti-parallel. Maybe Z will be anti-parallel and X will be parallel.
Okay. X will be parallel. Okay. Can you give the rationale behind this answer? Why do you think so? Anything you must have thought about? Why is alpha helix? May I know who is answering?
Because as you explain, alpha helix is continuous strand.
Yes. And
so it has more amino acids compared to Z and X. That's why I'm telling the Y is confirm alpha helix.
Okay, very good. See, you have understood the concept, but you are certain, like you are right about the alpha helix. Why is alpha helix? Now, why? Because like here in contact map, what do you understand? Like wherever, if the particular continuation, if there are hydrogen bonding, that is marked by a kind of rectangle. Okay, if there exists a hydrogen bonding. So here you are seeing that 31, let us say this is 31 and here 31. Okay, now there is a hydrogen bonding between this continuous chain because this is going in the right direction. This is also going in the right direction. So there is a continuity in the hydrogen bond formation in all from here to here. And these are interacting with here and here. Which one is interacting with whom? That is not clear, but still you see the continuous hydrogen bonding pattern. Okay, that is why Y is alpha helix. That exists only in alpha helix, right?
Alpha
so Y is
helix,
alpha helix. Now talking about the Z and X, here in Z, what happens in like anti-parallel? In anti-parallel, the hydrogen bonding occurs in the fashion of like see, if there is a parallel sheet, in the parallel sheet, you will have the hydrogen bonding like if it is going in from this direction, and then next sheet will be on the another direction. Okay, so what you will consider here, that it will have a 150-degree something hydrogen bonding, something like that, right? But what is the difference between parallel and anti-parallel beta sheet? That it may be the in continuous fashion, because these are like if strand is going from N to C and then it is taking a turn and then again continuing. So you see a hydrogen bonding more closer in anti-parallel beta sheets, and these are kind of a continuous. It might not be continuous, but it is not definitely not continuous in parallel sheets, right? Because if one strand is going in this direction, then there must be a difference, and then only the another sheet is coming, right? But it is a kind of a continuous, right? It is kind of a continuous. It may be continuous, it may not be continuous. So in that sense, it is taking a 180-degree angle, and that only can be possible when the like this amino acid is interacting with lower number of amino acid, like the distant amino acid. 60 is interacting with this fashion, and if it is going in decreasing order, if it is going in this fashion, in this direction, slope is negative, then these are the anti-parallel beta sheet. And if this is in the increasing order, because these are the parallel sheets, so in that sense, these Z will be the parallel beta sheets. So the correct answer here was option A. In contact map, if you see the decreasing angle, like decreasing slope of a particular sheet, then it will be a parallel and anti-parallel beta sheet, and another will be the, if you are seeing the increasing slope, then this is a parallel beta sheet. And if you, because these are interacting with the distant amino acid group, so these two are the beta sheets, and this one was the helix, because the H bonding is like it is continuous. So that is why Y is alpha helix, X is anti-parallel, and Z is parallel beta sheet. Is it clear to everyone?
Yes, sir.
Okay. So now the next question is, a sequence of amino acid is in a certain protein is found to be serine, glycine, proline, glycine. Now, can you identify which part of the sequence it will be? Will it be a part of anti-parallel beta sheet? Will it be a part of helix? Will it be a part of parallel beta sheet or beta turn? Any guess? Based on this question is based on the property of particular amino acid, chemical property or biochemical property.
Parallel.
What is, yes, parallel. Okay. Any other option? Any other guess? Normally, these kind of questions are being asked
Maybe
in GATE
anti-parallel.
examinations. Okay, anti-parallel. Any other option?
Beta turn.
Beta turn. Okay. Any other option? If somebody is giving some answer, can they give a rationale behind why they are thinking that answer is correct? So why anti-parallel beta sheet?
It can be beta turn, beta breaker होता है ना, proline, वो helix breaker.
Proline is not beta breaker. Yeah, it is helix breaker, alpha helix breaker. So definitely it is not alpha helix, right? So alpha helix is not in the option. Now, now we will think about the A, C, and D. So why anti-parallel beta C? And why beta turn? Why parallel beta C?
Only beta turn. I said parallel, but I will change it beta turn.
Beta turn. Why do you think so?
Because it is a breaker, so I would have marked beta turn.
And why do you think, like, can you give me rationale why it breaks the alpha helix? Why it is not present? Why it is called as alpha helix breaker? The answer is hidden in there only.
It has it makes a imide.
It makes a imino group. It makes a imino group, a chain that is known as a imino.
Imino.
Proline has imino group in the arc chain.
Yeah, and because of which it is yes, yes. Yes, somebody was talking. You can go ahead. Okay. So in that scenario, like because proline has a bulkier group, it is not kind of a bulkier group, but it does not exist in the cis form. It normally exists in the trans form. Okay, when two adjacent amino acids are there, and also because of immuno group, its side chains have stereochemistry imposed on the surrounding amino acid, and because of that, it cannot take a turn. It cannot be in a continuous chain, whether it is a parallel sheet or whether it is a helix. Normally, it exists in a loop or where the protein is turning. Same goes with the glycine. Why? Because glycine is the simplest amino acid, right? It is the simplest and lightest. Like it does not. So because of that, it can fit anywhere. Okay. So when you see the rich proline or glycine, so normally you can think that particular part of a peptide chain is either in the loop or in random coil, and it normally takes a beta turn. So the correct answer here was beta turn. Why it is alpha helix breaker? Because it contains imino group, because of which it does not fit in the alpha helix form, because it cannot rotate, right? It has a rigidity, because of which it does not fit in the helix, and similar things goes in the case of anti-parallel or parallel beta acid, because the hydrogen bonding is not much optimum in case of parallel and like when proline is present in the parallel and anti-parallel beta acid. So normally this glycine and proline fits in the turn or random coil part of the particular protein. Is it clear to everyone?
Yes, sir.
Okay. Okay. Now the next question is, a D amino acid would interrupt an alpha helix made up of L amino acids. Another common naturally occurring constraint on the formation of alpha helix is the presence of option A, negatively charged arginine residue, option B, positively charged lysine residue, option C, two glycine residues side by side, option D, a proline residue. What do you think? What are the constraints to form the
A
alpha
proline
helix?
residue.
Very good. We have just discussed this question. So the next question is the most important contribution.
Yes.
Yes. So the most important contribution to the stability of protein conformation appears to be option A, sum of the free energies of the formation of two weak interaction. This is related to the thermodynamics of protein folding or the thermodynamics of kind of bond formation. Okay. So the question is the most important contribution to the stability of protein conformation appears to be the sum of energy of the formation of many weak interaction between its polar amino acid residue and surrounding matter. Option B, sum of free energy for the formation of many weak interaction among the hundreds of amino acids in protein. Option C, entropy increases from the reduction in ordered water molecule forming a solvent cell around it. Option D, maximum entropy increases from ionic interaction between the ionized amino acid in a protein. So what is the probable answer? Any guess? What contributes mostly in the stability of protein conformation when a protein is present in an aqueous solvent?
To stabilize the protein, more hydrogen bonds are required.
Yes, very good. Then based on that knowledge, can you
So
attempt this
it may
question?
be
A. Some of the free
A,
energy formation
B.
of many weak interaction between its polar amino acid residue and surrounding water. Any other answer?
C.
C. Entropy increases from the reduction of ordered water molecules forming a solvent cell around it. Another option? So if you have studied the thermodynamics, can somebody tell me when a particular state is being reached to a stability, then the entropy should increase or decrease?
Decrease.
Decrease.
Entropy should decrease or increase?
Decrease.
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 Okay. So what happens in spontaneous reaction? Entropy is increasing or decreasing? Normally, entropy. Yes.
In spontaneous reactions, entropy increase probably.
Entropy increase. Okay. And in what case in what scenario entropy decreases? And if entropy is increasing, then this structure will be ordered or disordered?
It will be disordered.
Disordered.
Disordered, right? The molecules or atoms that are there, they will be in disordered form. Then only entropy increases, right? So here, the most contributing factor is the C option. Why? Because let us assume you have a protein chain, and it is there in a and you have a water as a solvent, and you put in the when protein is not there. Okay, so in that case, water will be in some state which will be the highest maximum stability of water molecule. There will be hydrogen bonding between them, right? What happens when you put this protein molecule in this particular water solvent, aqueous solvent? So what will occur? So in that case, whether the protein will stabilize, how this conformation will occur, that depends on how much energy this disorderness gives to this particular protein folding. Okay, in that case, the ordered water molecule is segregated and there will be a reduction in order. So in that case, the entropy will increase. Okay, so but this increase in entropy is substituted by the formation of hydrogen bond around this particular protein molecules, because if two water molecules are present in a aqueous solvent, maximum hydrogen bonding that is possible is how many hydrogen bonding can a water molecule can have?
2.
2 or more than that? Think about it. Okay,
3.
so
3.
whatever if how many?
3.
3. Okay, any more? Normally water molecules can have maximum 4 hydrogen bonding. Maximum of 4 hydrogen bonding. And now if protein is present, then that particular water molecule can surround this protein. Okay, and because of the solvent cell, this protein conformation is being stabilized, and which substitute this increase in entropy. And this mostly contribute. This is the most important contribution for stability of protein conformation in aqueous solvent. So option C was correct here, because when ideal water is present, in that case there will be some kind of hydrogen bonding in the in its state. But when you put protein in it, so this hydrogen bonding will break, and the water molecule will rearrange itself to make a solvent cell around the protein, which makes it feasible to protein to be being in correct order or in a correct conformation. Okay, so option C was correct here. Now the next question: which of the following amino acid is likely to be found in the middle of alpha helix? Least likely to be found in me.
Proline.
Very good.
Proline.
Yeah, we have discussed this. Now, why? Because proline bonds to two alkyl group, it gives a planar configuration because imino group is present and imino group is in a planar. So if planar conformation, if a particular amino acid is achieving planar configuration, it won't be participating in the rotation, because alpha helix should rotate, and a particular amino acid that will attain, that is 100 degree. Proline cannot rotate itself to the 100 degree, so that is why it is inhibited. It is not present in the alpha helix conformation. Right. So now the next question is: in a sequence of amino acid within an alpha helix, between which amino acid in the sequence does hydrogen bonding occurs? So for every how many amino acid hydrogen bonding will be there? 1 and 6. So every 6 amino acid. 1 and 5. So every 5 amino acid. 1 and 4. So every 4 amino acid. 1 and 6. So every 4 amino acid. 1 and 3. So every 3 amino acid. What is the correct option here? Any guess?
1 and 4.
1 and 4. Are you sure about it?
Yeah, I guess.
1 and 3.
Okay. 1 and 3 means option E. Okay. Any other option? What is the hydrogen bonding pattern in alpha helix?
In alpha helix, it is I and I plus 4.
I and I plus 4. So if I is equal to 1, then I plus 4 will be
B.
yes. So in alpha helix,
Plus
yeah,
4,
I plus
5,
4.
then
I
B.
plus
Option
4
B.
means 5. So 1 and 5th.
I.
Option B. Very good.
It's B.
So in alpha helix, first bonding to the 4th, and then the second to the 6th, third to the 7th, and so on. So every 5 amino acid there will be hydrogen bonding. First to the 4th, second to the 6th. Sorry. I to I plus 4. The explanation is somewhat incorrect here. Skip it. So the next question is: the formation of TAS is determined by TAS interaction, whereas the formation of TAS is strongly influenced by TAS interaction. Your options are: the formation of alpha helix is determined by the short range interaction, whereas the formation of beta strands strongly influenced by is long range interaction. So option B: alpha helix, long range, beta strand, short range. Alpha helix, long range, alpha helix, short range, and beta strand, short range, beta strand, long range. What What is the probable answer for this?
A.
Option A. So normally alpha helix occurs in short range and beta strands occurs in long range. Very good. Option A is correct here. Next question, which property is shared by both myoglobin and hemoglobin? Both are saturated with oxygen at low concentration. Both display cooperative bonding when transporting oxygen. Both contain strands of beta pleated sheets and zigzag shape, and both contain large segment of alpha helix with a spiral shape. 11th. Yes, option C. Both contain strands of beta pleated sheet and zigzag shape. Okay. So can you first tell me what are hemoglobin and myoglobin, where they are present? These are, and what is its property? What is
Hemoglobin
hemoglobin?
present in RBC.
RBC. Okay.
Respiratory
And
pigment.
very good. And what about myoglobin?
Present in muscle.
Yes, presents in muscle. And what is its role?
Transport of oxygen and
Yes.
CO2, O2 and CO2 transport.
Yeah, both myoglobin and hemoglobin both are involved in the transportation of oxygen molecule. Okay, so and also what occurs here is, like hemoglobin is normally it follows a kind of a cooperative bonding. Cooperative bonding means the first when there are four subunits in hemoglobin. Okay, there are four subunits in hemoglobin, 2 alpha and 2 beta, and these are attached with the hydrophobic interaction. Now in all subunits there is a heme group which interact with oxygen. So when one oxygen molecule is attached to this heme group, it makes the rearrangement in other uh, kind of subunit also, so that the more oxygen it increases the affinity of the binding of oxygen to other sides, and thereby it acts as a cooperative bonding. But that does not occur in myoglobin. Myoglobin only have two subunit. Okay, and it has two binding, but it does not act as a cooperative binding. But both amino, like both this protein has larger alpha helix, and these are in the spiral shape. So obviously hemoglobin is supporting the cooperative bonding, but myoglobin does not. So option B is incorrect. Both are saturated with the oxygen at low oxygen concentration. This is also not correct, because myoglobin act when the low oxygen concentration is there, but hemoglobin also act as a it act as in when a high concentration is there. Myoglobin is present in the muscles, so when the low oxygen concentration is there, then also myoglobin can accept the like oxygen molecules and bind to it and transport it in the muscle. Okay, so option A is also incorrect. Both contain the beta pleated sheet. It is not formed. Majorly, you find alpha helix in myoglobin and hemoglobin. Both are the globular protein. Globular protein are nothing but, why we term those as a global protein? Global protein means it has higher alpha helix. So the both contain large segment of alpha helix with spiral shape. So option D is correct. Now the next question is determination of precise spacing of atoms within a large protein is possibly only through use of which kind of analysis? Option A, Ramachandran plot. Option B, molecular binding, molecular model building. Option C, X-ray diffraction. Option D, contact map. We have discussed the contact map just before. Ramachandran plot you have studied. Then molecular model building and X-ray diffraction.
Answer
These
is
are the
contact
two
map.
new terms. Contact map. Okay. And any other guess? This is talking about the precise spacing of atoms.
Diffraction.
Okay, diffraction,
X-ray.
X-ray diffraction. Any other option? What does Ramachandran plot maps? What do you study in Ramachandran plot? Can somebody, you have studied Ramachandran plot. Can somebody tell me what are the x-axis and y-axis in Ramachandran plot? Okay, Ramachandran plot is nothing but studying whether the protein is in the right conformation or not, and that we decide using the mapping phi and psi angles, right? Phi and psi angles. The angle between phi and psi that determines whether because Professor G. N. Ramachandran he studied the different proteins, and then he concluded that there exists a allowed region of in any case of protein folding. Okay, in case of peptide chain making on protein folding, there are certain allowed phi and psi angles that occurs in beta pleated sheet or in alpha helix. So Ramachandran plot talks about the dihedral angle. So the option A is incorrect. Molecular model building are computational tools that tells you how like protein may be folded, and that takes the integration of algorithms such as how to fold a protein. So molecular model building is also not an correct option to study the spacing of atoms. Contact map that we had studied that talks about what kind of hydrogen bonding or interaction that occurs in the peptide bonds, right? In two amino acid, contact map means in a particular chain which amino acid is interacting with in what fashion, so that whether a particular pattern is alpha helix or beta sheet, that is being studied in contact map, but it does not talk about the atoms, spacing of atoms. That only you can do the analysis using the XRD. XRD is also known as the X-ray diffraction. Okay, in X-ray diffraction, that the correct answer here is XRD. So I will talk more about XRD in the end of the lecture. Okay, because this is a part where like analysis, when you are studying a protein structure, then XRD is an important tool. So I will talk about this in the later slides. So which of the following statement is about oligomeric protein is incorrect? Options are: a subunit may be similar to others. Option B, all subunit must be identical. Option C, some oligomeric proteins can further associate into large fibers. Option D, some subunit may have non-protein prosthetic groups. Yeah, the question is about oligomeric proteins. What are oligomeric proteins? Yes.
On protein.
What are oligomeric? Means there are more than one monomer in a protein structure, in quaternary structure, right? Okay. So oligomeric means there are more than one monomer. So can somebody tell what is the incorrect statement? Does having a oligomeric
Option B.
need to be talk about it? Option?
Option B. All subunits must be
Option
identical.
B. Yes, you are very much accurate. This is incorrect statement about the oligomeric protein, because oligomeric protein may have the different subunits, right? As I have just discussed about the case of hemoglobin. Hemoglobin have two types of oligomers. There are total 4 subunits, alpha 2 and beta 2. So alpha 2 and beta 2 suggest that there are 2 unidentical subunits also involved in the formation of quaternary structure. So it does not like it is not the property of oligomeric. There can be the different subunits attached in an oligomeric protein. Now the next question is, which of the following statement is not true about the secondary protein structure? Options are hydrophilic and hydrophobic character of amino acid residue is important to secondary structure. Option B, the ability of peptide bonds to form intramolecular hydrogen bonding is important to secondary structure. Option C, the alpha helix, beta pleated sheets and beta turns are example of protein secondary structure. Option D, steric influence of amino acid residue is important to secondary structure. Which one is incorrect regarding protein secondary structure? Any guess?
The ability of peptide bond to form intramolecular hydrogen bond.
It's B. Maybe it's B.
B.
The ability of
Okay.
peptide bond to form it.
Other option? Does anyone have other suggestion? Yeah, option?
D.
Option D. Okay. Any other suggestion?
Sir, A.
Okay, A. So can someone give the rationale behind all 3 options what they have selected? Why option D? Why do you think it is incorrect regarding the protein structure?
Because the peptide bond which contains CONH, it is not involved in the intramolecular hydrogen bonds.
Okay. Means like option D was the steric influence of amino acid. Okay, you were talking about the option B. So ability of peptide bonds to form the intramolecular hydrogen bond is important to secondary structure. So is it incorrect regarding the secondary structure of protein? What do you understand by secondary structure of protein? Secondary structure of protein means formation of alpha helix and beta pleated sheets, right? And what kind of interaction do you see in alpha helix and beta pleated sheets? Those
Peptide
are the
bonds and hydrogen bonds.
peptide bonds participate in the intramolecular hydrogen bond. So that is why option B is correct, right? It is not incorrect in case of secondary structure. And option C is also the similar, like alpha helix, beta pleated sheets and beta turns are example of protein secondary structure. This is correct, right? So option B is also correct about protein secondary structure. Now coming to the option D, the steric influence of amino acids is important to secondary structure. Is it correct or incorrect? It is very much correct.
Sir,
Why?
what is steric
Residues.
influence?
Yes.
Residues.
Steric influence means like in case of immuno group, proline. Proline does not rotate, or it does not fit in the kind of a chain. Like in linear chain, proline does not occurs, because of which, why? Because it has immuno group, a ring shaped structure in their attached to its alpha carbon, because of which it imposes a steric hindrance on the formation of turns, like on the formation of alpha helical turn, because of which the proline does not support the formation of alpha helix, or which alpha helix is also a secondary structure, right? So steric influence does effects on the formation of secondary structure. So option D is also correct, right? Regarding secondary structure, the only incorrect thing is hydrophilic or hydrophobic character of amino acid residue is important to secondary structure. This is incorrect because whether it is hydrophobic or hydrophilic, it does not determine whether the protein will have secondary structure or not. Because in in alpha helix you can have hydrophilic or hydrophobic amino acid residue. In beta pleated sheet also you can have the both kind of hydrophilic and hydrophobic characters of amino acid. So it is, and it can also be in the turns or loops. So it does not depend, it does not impact on the formation of secondary structure. That is why option A is the correct answer for this question. It is not true about the secondary protein structure. Okay, is it clear?
Yes, sir.
Okay. So the
Yes,
next
sir.
question is, very good. So the next question is, indicate which secondary structure or structure of the following peptide is likely to adopt in its aqueous solution of pH7. Now you have a sequence of glycine, alanine, glycine, alanine, glycine, serine, glycine, alanine, glycine, serine, glycine, alanine. So which kind of formation it will take? Whether will it be alpha helix, beta pleated sheet, random coil, or turns? What is the most
Turn.
probable? Turn.
It's D.
Okay. Any other? Any other guess?
C.
B. B or
Random
D?
coil. Random.
C. Okay. Okay. Anyone thinks about alpha helix? Does anyone have guess regarding alpha helix? What is the contribution of PS7 here? What will it have influence on the structure formation? Okay. Anyone in the favor of B, option B? Alpha helix is not an correct option here because I have already told that alanine or glycine both are the simplest amino acid. Also, glycine is achiral. So, and these are the smallest, like very small side chain, and they can fit in anywhere. So, because of that, alpha helix is uh, not the case at the when this peptide chain will make a secondary structure. So, what are the other options between B, C, and D? The correct answer here is beta pleated seeds. Why beta pleated seeds? Because here you are seeing the alanine is also present. If only glycine was there, glycine or proline, then it may be most favorable that it forms a beta turn. But in case when the alanine is also present, in that case, it it will favor in the formation of seeds. Okay, whether it is parallel or anti-parallel. So the most probable structure at PS7 for this particular peptide will be beta pleated seeds. Because only in that scenario the maximum hydrogen bond can be formed. In random coil the hydrogen form will not be much optimized. Okay, but in case of beta pleated seeds, this can bend over or this can form a parallel or anti-parallel kind of structure where they can optimize their hydrogen bonding pattern, because of which beta pleated seeds are the correct form that this peptide will adopt its at the PS7. Okay. Now the next question is, which of the, is it clear to everyone why it is beta pleated seed? Because of maximum
Yes.
hydrogen bonding formation in this particular chain,
Yes.
right? Now the question number 16 is, which of the following is not observed in the contact map? Options are: alpha helix appear as thick band along with the main diagonal. Option B, parallel beta sheet appears as a thin band parallel to the main diagonal. Option C, alpha helix appears as a thin band perpendicular to the main diagonal. And option D, anti-parallel beta sheet appear as a thin band anti-parallel to the main diagonal. Which of the following is correct? Is not correct. Is not observed in contact map. I had previously I had discussed about the contact map. So I for ease, I will make a contact map here, a particular contact map, the previous one only. Here is the amino acid number. Okay, and you see stand here, then stand here. It might be like this, and then it might be like this. Okay, now can somebody tell me which all are the conformation, and then you can correlate with what is this representing? In this
Alpha,
contact map, this is
alpha
alpha
helix.
helix, right? Alpha helix, very good. And alpha helix, where does it occurring? Whether it is parallel to the what is the main diagonal here? Main diagonal will be
along,
from
along the
origin to this,
diagonal.
right? So the alpha helix appears as a thick band along the main diagonal. Is it correct or incorrect?
Option A
It
seems
is
incorrect.
correct.
Option A is correct. Okay. Option B, parallel beta sheets appear as a thin band parallel to the main diagonal. Is it correct or incorrect? It is also correct, because when you have a thin band around the parallel beta sheet, around the main diagonal, alpha helix will only occur in the main diagonal. When you see the parallel thing, whether it is thin or thick, parallel to the main diagonal, those will appear as a, because they have the like which shape. This is the diagonal shape, like perpendicular. In the negative slope, this will be the anti-parallel, and these are the parallel in positive direction, right? So the parallel beta sheet will appear as a thin band to the, whether it is thin or thick, that does not depend. So it will be the parallel to the main diagonal. So option B is also correct. Now option D, anti-parallel, will appear as a thin band to the anti-parallel to the main diagonal. It is anti-parallel, right? It may be the perpendicular, it may not be on the perpendicular direction. Okay, so option D is also correct. The only incorrect option is alpha helix appears as a thin band perpendicular to the main diagonal, because it is around the main diagonal, so it is not perpendicular, right? Alpha helix you will find on the main diagonal only. So option C is incorrect. So the correct answer here is option C. Is it clear?
Yes, sir.
Okay. Now the question number 17. In an alpha helix, the R groups on the amino acid residue are found to be outside the alpha helix spiral, generate the hydrogen bond, to form the helix, stack within the interior of the helix, or alternate between the outside and inside of the helix.
Option D, alternate between outside and inside.
Okay. Any other options? What are R
Yes,
groups?
D, alternate between outside and inside.
Okay. Can somebody tell what are R groups in amino acid?
Side
These are
chains
side
of
chain, right? Side chains. Side chain
Yes.
of an particular amino acid, right? So normally when you see the alpha helix, like alpha helix goes like this and this and this. Okay. Interior means inside. And exterior means outside, protruding towards outside. Right. So what do you think will be the correct kind of conformation when the alpha helix is being formed? If it is inside, if R group is inside the group means when you are seeing from this direction, it will appear as a this kind of helix structure. So if there are R group inside it, so will it create a kind of hindrance?
Yes, sir.
Yes. So in that scenario, this will be the most destabilized form, because R group may impose. There are different type of R group in among all 20 amino acids, right? So when two amino acids, when R group will be in the like interior, it will impose a steric hindrance, because of which R groups are mostly protruding outward. It is not inside. So the correct answer here is 17th one. The correct answer here will be option A. These are found to be outside of alpha helix spiral. Okay, is it clear?
Yes, sir.
Okay, the next question is, which of the amino acid is found in beta terms? Quick questions, because we have just revised it. In beta terms, which of the probable, which among the following we will find majorly?
Proline again.
Proline, right? Now the next question is, a dash and is the form in the anti-parallel beta seed, where the first and last strand connectivity via hydrogen bonding. So the answer already appeared. Okay, so this motif will be beta barrel. In beta barrel, the anti-parallel beta seeds are normally arranged in such a fashion that they form a kind of a channel. Beta barrel are normally found in the membrane protein, where they form as a channel to transport one molecule from inside to outside of the cell in a lipid bilayer. Okay, and these beta barrel are formed by the anti-parallel beta seeds, because anti-parallel beta seeds can come closer and they can by which they can form the maximum stable hydrogen bonding, which is 180 degree angle, and because of which anti-parallel beta seeds form a channel. Okay, now this summarizes the complete week 2 discussion about the protein architecture. Regarding the tomorrow's exam, if this falls under the case of biomolecules and studying the structure and bonding. Other than that, I have also prepared a kind of a question from this topic. This is a Edmond degradation process. Okay, these are the biochemistry technique to analyze, and this is also important in case of research perspective and analytical part of chemistry, analytical chemistry or analytical biochemistry. Research perspective, why? Because let us say you have isolated a protein. Okay, and then you want to know which all amino acids are there in this particular protein. You have isolated the protein, it is forming a polypeptide chain. Then what you to identify which all amino acids are there using the analytical technique, what you will do, you can follow this Edmond process. This is called the Edmond process. Edmond process. So in Edmond degradation process, what you do, you use a chemical which is known as the phenyl isothiocyanate. So what does this chemical do? This comes and bind to the N terminal of a protein of that particular polypeptide. So if it is binding to the N terminal, so in that N terminal, it and this arrangement, like this attachment, only occurs at high pH. See, you have in one cuvette, in one reaction chamber, like in one cuvette, or you have polypeptide, and then you put this phenyl isothiocyanate at high pH, then it will attach to the N terminal of that particular protein, and then chemical rearrangement will occur. And when you decrease the pH, then rearrangement will occur. This will form a complex with the first amino acid, and this will be the anylothiazolone derivative of any amino acid residue. The first amino acid, this is the first amino acid, N-terminal, and at low pH, the rearrangement will occur, and this bond will dissociate, and this will result to a shorter peptide, one shorter amino acid of peptide. Okay, and this will give you another compound, the complex of phenyl isothiocyanate. and at low pH you can separate from this reaction, and then you can analyze which amino acid it is. Okay, so this will be your terminal polypeptide. So by this you will know which amino acid, which is the first amino acid here. Okay, and the peptide which is rest from like when you dissociate first amino acid from it, then again in the N terminal you have the same in the peptide you will have N terminal. Then this shortened peptide, which is one amino acid less, you will purify it and then you will recycle it using the same process. At high pH you will add phenylisocyanocyanate, it will again bind to its first amino acid, and similarly it will dissociate one by one. You will have the kind of a set of samples, and then you will analyze it using the HPLC or any other identification technique, and then you will understand which particular amino acid it is, and by that you will know the entire sequence of amino acid of that particular protein. Is it clear? This is known as the Edman degradation process, and using this fragmentation technique you understand the complete sequence of that particular protein, which particular amino acid is involved in that protein. Is it clear? This is important. This is important for analytical biochemistry, and which is part of your like GATE examination. The another question, to analyze, like now you have done, now you have fragmented your peptide chain in one amino acid, or whether or you have also, or another technique to like check which all amino acids are there in your peptide chain, that you can do by mass spectroscopy, mass spectrometer. So mass spectrometer process is given here. The first thing that you have protein sample, you have digested it, enzyme digestion you have done, and you have shorter peptides. Now these shorter peptides you can pass through the chromatography column. Okay, now through the chromatography column you will have the different samples based on the size, based on the charge. You can separate the different samples from it, and then you can subject this channel to the gas chromatography or mass spectroscopy. In mass spectroscopy, what you will do, these fragmented protein samples will be subjected to the like based on the mass of these fragments, and also based on its property. When you subject that sample to the mass spectrometer, this based on the MYZ ratio, you will find the different peaks, and then you find the library, you subject that library, and then you will find that this particular chain is present, this particular sequence of amino acid is there, and thereby you sequence the entire amino acid, entire protein. This is a flow chart where you have a global protein, you digest it, and then it forms a peptide mixture. Now you pass it through the multidimensional chromatography, and then you have a sample. Finally, using the tandem mass spectroscopy, you can have the different spectrum. You then you subject that to the database of the various characteristic of MYZ. There are different MYZ ratio for different amino acid. You match that library, and then you finally come up to the peptide analysis, and you finally get the result, like which all amino acids are present in your peptide chain. So is mass spectroscopy is clear to you? This was another technique based on the identifying the amino acid sequence in a given peptide. Now let us say you have like a protein in your human, like in your sample, like you have a cell lysate. Cell lysate means hydrolyzed, like a cell you have digested. In that cell digestion you add a drug, and you know that particular protein you know that particular protein is interacting with the drug. Okay, this is a kind of a bonus to you, like how there are set of unknown proteins present there, and you want to analyze which protein is being stabilized, which protein is being bind to that particular drug or small molecule. So what you will do, you will add a vehicle in that cell lysate and a drug. So the principle of drug affinity responsive target stability is what? That if that particular drug is attached to the protein, then it will stabilize its structure due to the binding. Okay, so when you do the proteolysis means you add a protein cleavage enzyme, like protease enzyme cleaves the protein peptide bond. Okay, so when you subject both samples in proteolysis sample, so in which the small molecule is not existing, that particular peptide will be digested completely. But when the sample in that sample, if a particular protein is interacting with that particular drug, if it is bounded, then the proteolysis cannot affect that particular protein, and you will have that particular drug target. Then this is important to analyze whether that particular small molecule is binding with that protein or not. Then you run SDS page and you identify where you have found the thick bands. Okay, these are the undigested bands. Undigested band, in this particular band, this particular amino acid has been attached to this drug molecule, and that is why it is stabilized and it is not cleaved by proteolytic enzyme. Now what you will do, you cut out this lane, and then you will follow the mass spectroscopy technique. And using that, you can analyze, you can identify what is your drug target protein. So this is known as the drug affinity responsive target stability. Means due to the binding of drug, that particular target protein is being stabilized, which is not being cleaved by the protease enzyme. Okay. Now we are talking about the XRD. XRD is used to analyze the structure, the two like representation, like where that particular atom, like in a particular protein which is 316 amino acid length, if you know a protein which has 316 amino acid residue in its structure, then if you want to know what are the precise location of particular atoms in that protein, because in one amino acid there will be multiple atoms, right, based on its structure. So if you want to map or you want to generate a 3D structure of that particular protein, that can be done using the XRD technique. So in XRD technique, how you do it? This is the principle of analyzing the interaction of wave with the atoms. Like we use X-rays because X-rays are smaller wavelength than the atomic like bond length. Okay, and they are in the size range of their wavelength in the size range of atomic radii. So because of which the X-rays can be deflected by a particular atom. Okay, so how you do it? You put a source, X-ray source, and you only pass certain X-rays through the pinhole. Now in the path of traveling this X-ray, you put your crystal. Crystal is nothing. This crystal is your protein crystal. Okay, so and you continuously rotate it. So when this X-ray beam impart one particular atom in this crystal, it will be diffracted. If it is diffracted, you can check the angle, and based on the n lambda is equal to 2d sine theta. Based on this equation, you can map the different atoms in your protein, and you have different map based on the rotation of the crystals. Okay, based on it, you can map how the crystals are oriented, and that is how you generate the entire protein structure. Okay, in which fold it is, like where the alpha helix is, where is beta sheet, where is beta turns. So those geometry you can attain using the XRD. The more will be in upcoming lectures. When you go further, you will find these lectures. Now, another tools which will be essential to understand the protein architecture is CD spectroscopy. CD spectroscopy is also known as spectroscopy is also known as circular dichroism spectroscopy. Okay, so what do you do in circular dichroism spectroscopy? You put a white light source which is unpolarized light. Now, unpolarized light means it does not have any direction. When you pass this unpolarized light using the monochromator, it only favors, it only allows a particular wavelength of the of this like it only favors one particular wavelength to pass on through this monochromator, and you have a a light which is only one direction movement. Now you pass through it polarizer, then it will form it will polarize the light, and whether it will be in the right circularly polarized light or left circularly polarized light. Okay, so once you put the sample in between this path, then this sample will rotate its like angle. So how much angle it has been rotated, that you map using the CD spectrometer, like wavelength of light and how much degree it has been rotated. This polarized light, how many angle it has rotated. Based on it, it maps this angle and wavelength, and that is how you get the which kind of secondary structure it is. How, what is the composition, how much percentage it has alpha helix, this particular protein, how much percentage is the alpha helix, how much percentage is the beta sheet. So normally alpha helix gives a peak in the range of 220 nanometer and here, and this blue represents the beta sheet and black line represents the random point. Okay, so these are the references that you can follow, and if you have any doubt you can ask me, or you can also post in the forum. This concludes the this like live interaction. Any doubt?
No, sir.
Okay, so you can give your feedback in the course feedback form, that is also that is already available in the course portal. Okay, and if you have not, if there are some people, if they have joined using my LinkedIn channel, they can join the course. Course registration is still open. And if you are like if you have any further doubt, like you can go through the recording of this lecture on my YouTube channel. My YouTube channel is this one, WinBioCB 2022. Here you go to this channel, you just search handle WinBioCB 2022, subscribe to this channel. I have created a playlist, this live session for biochemistry. Here I have posted the previous session also, video of previous session. You can also find my previous course run, the live interaction session in the previous course run, which was on the fundamental protein chemistry. And I also conduct online internship, WinBioCV, which is winter internship in bioinformatics and computational biology. So all the channels, the interaction, and you can find the like YouTube recording there also. Okay, so follow this channel, subscribe to this channel, and you can also ask the question, your doubt in the comment box, in the description box of a particular video. I will upload the this like recording, or I will upload the PPT, link of this PPT, which you can also find in the course forum. Okay, in the description box, I I provide all the information regarding the NPTEL course, and the you can find the lecture handout folder on this link. Okay, that I have shared. Or NPTEL team will share this document, Excel sheet, which is the consolidated form of like all the recording of the YouTube link and then presentation folder. You can find it there. This Excel sheet will be shared to you, all the course participant. This link also I have provided in the beginning of my slide. You can get it from there also. I have created a WhatsApp group for this course. You can join using this course, using this WhatsApp link. Okay, and if there are any other doubts, you can ask in the discussion forum. Discussion forum is there, and I always post the recording at the end of every session with the PPT in it. Okay, so thank you so much for joining, and this by this we can conclude this session if you do not have any doubt. Okay, I hope you will
Thank you so
join
much,
in the
sir.
next session also. Thank you. Thank you and welcome everyone. And I hope you will join in the next session also. I am ending the session.
Yes.
Okay. You
Thank
go
you, sir.
find the recording on my YouTube channel.
Thank you, sir.
Thank you so much. Welcome.